Okay, guys, so this is the last section or unit or however I want to call this in conic sections. It's called a hyperbola. And this is probably the hardest one because there's just extra, I'm doing air quotes just so you guys know, extra rules that you have to pay attention to. So here we go. The standard form of a hyperbola centered at HK is. So we have two different ones. We have when it opens horizontally, and when it opens vertically. Okay, so there's actually two different equations for this. So when it opens horizontally, it is x minus h squared all over a squared minus y minus k squared all over b squared equals 1. Okay, so notice the only difference between the equation for this hyperbola and the ellipse is what? Well, the minus sign. Okay, that's the only difference. Everything else is the same. Okay, so when it opens vertically, it is this. Y minus k squared over b squared minus x minus h squared over a squared equals 1. So now if you look, if it opens vertically, the y comes first, and that's the big difference, the y and the b. And I do want to make sure that you're aware of the b. Look, the b is always with the y, and the a is always with the x. So make sure that when you do these, you know the difference. And it will really come out when we are graphing this or trying to write trying to find the center of your equation from these. So that is that's going to be where the problem is. I just want to say. So now we have one more little part for our definition, and that's where our vertices at. So I'm going to just say with vertices. And we'll talk about this in a minute. You're like, with vertices, what are you talking about? Well, I'll show you in just one moment, okay? So if it opens horizontally, it's vertices at H minus A, K, and H plus A, K. And if it opens vertically, it's H and then K, comma, K minus B and H K plus B. Okay, so I'll show you what that means all in just one moment. We have a little, I know this is a long definition. I just want to talk about it for you guys are going to be like, what? But it is a longer definition, so that's why you have so much space on here. The next thing we want to talk about is a hyperbola has a fundamental rectangle. Has a fundamental rectangle. Okay, so with corners, I'm not sure I like this definition, but as I start looking at it, with corners, but that's the one that was given, and so that's what I'm going to use. 0, B, comma, 0, negative B, A, 0, and negative A, 0, okay? Then the last thing is the diagonals. diagonals of this rectangle are the asymptotes. Okay, so now I'm going to show you all those features that we're talking about. So you'll be like, what? So here we go. So here, if you can see the dotted line here and here, the box, you can see the box. That's my fundamental rectangle, okay? Woo, can't spell rectangle today. Fundamental rectangle. Okay, so here is, and I'm going to show you, oh, that's, okay, there we go. Let's see. Here's my point here with vertices. So it says with, here's my vertices here. You can see it says with the vertices it was talking about up there, right here and right here, or right here, right in the middle of my, they're in the same line with the center of my fundamental rectangle, or I can't even see where I'm drawing my line at. Here we go. It's in line with the vertex of my fundamental rectangle where the asymptotes, and if you can see this right here and right here are my asymptotes, okay? Symptotes. And then the hyperbola is on each side inside of those asymptotes. They're drawn. They don't cross those asymptotes. The asymptote, remember, that is the definition. The definition of asymptote is a line that my graph does not cross. So my hyperbola is drawn inside of those asymptotes. They're separated by the distance of my fundamental box and confined by my asymptotes. So that's why I need to know what A and B are. That helps me with my fundamental box. A and B is still the distance from the center of my box. So I'm going to say the center of my box this time. A is the distance horizontally still. B is my distance vertically. And then I'm going to draw a dotted box so I can find out where my fundamental rectangle is. And then I have to draw in my asymptotes. And those are also dotted, as you can see in this picture. And then if my X is first, they open horizontally, and if my Y is first, they open vertically. So this is just more involved. You have to understand what your equation is telling you when we do this. So that's why it's a little bit harder to do this one. So you just need to slow down a little bit and take a little bit more time. But we're gonna make it through here. So here we go. We're going to actually, I think we're going to write the equation. We're going to use the information provided and write the equation of these. So again, I want to find the center. I always need to know the center. Okay, so where's my center? Well, my center is here. So my center is 0, 0. And here you can kind of see your box. It's very faint, but it is a little, it's a little teeny bit darker, but it is there, and it's not dotted. Sorry, the program that I got this from doesn't dot it. So when you're drawing it, it does need to be dotted. And A is my distance horizontally, and B is still my distance vertically. So my distance horizontally is 3. My distance vertically is 3. That's perfect. Now I need to decide, is it opening horizontally or vertically? Well, you can see my blue line. It's opening horizontally. It's opening over the x-axis. See, it's opening around my x-axis here. Here is my, oops, wrong thing. Here's my graph here, and here, and it's opening around the x-axis here. It's opening on the x-way. So, X comes first. That's how I kind of tell that I know my X is going to be first. So I know I have X minus 0. squared over a squared, which is 3 squared, minus y minus 0 squared all over 3 squared equals 1. So if I simplify this, I get x squared over 9 minus y squared over 9 equals 1. And there's my equation for the graph. So we're going to go ahead and go on to the next one, and we're going to try it. Okay, so again, we need the center, and then we need to know what A is, and we need to know what B is. So my center is where my asymptotes cross. So this is 0, 0. And then horizontally, it's 1, 2. And vertically, it's 1, 2. Okay, so now this time, my graph, as you can see, it's kind of wrapped around, and it's going up and down, so that means it's around my y's. Okay, so that means my y is going to go first. And this is what you have to make sure, that the y is going first. So it's going to be y minus 0 squared all over b squared, which in this case, they're both the same b. But make sure if your b is different, this is b squared minus x minus 0 squared all over a squared equals 1. So if I simplify that, I get y squared over 4 minus x squared over 4 equals 1. And there you go. Okay, I think we have a couple more of these ones to do. Let's see. Yep, we got 2 more to do of this one. So here we go. So again, I need to find the center. I need to find A, and I need to find B. So the center of my hyperbola is right there. It's at 1, 2. And horizontally, can you kind of see the box? That's right here. There we go. So it's 1, 2, A is 1, and B is, A is 2, and B is 1. Okay, and it is opening. Which way is it opening? Well, it's opening this way. Okay, so I've got x minus, it's opening up. So look, I did that wrong. I said make sure that you're doing it the right way. So it's opening up, so y needs to come first. So I've got y minus 2 squared all over b, so that's 1 squared, minus x minus 1 squared all over 2 squared equals 1. So now if I simplify that, I get y minus 2 squared over 1 minus x minus 1 squared over 4 equals 1. Good job, guys. Okay, one more and we're done with this. Okay, so here we go. Pardon me. Here's the center. And then here, you can kind of see it, is my box. Okay, so my center is at, let's see, that looks like it's at 0, -1. And A is at 1, 2, 3, 4, 5. And B is at 1, 2, 3, 4. Okay, so here we go. So I've got, oh, and it's opening. Which way is it opening? Well, it's opening horizontally, so that means x is first. So I've got x minus 0 squared all over 5 squared minus y minus a -1 squared all over 4 squared equals 1. So x squared over 25 minus y plus 1 squared over 16 equals 1. And there's my answer. Okay, good job, you guys. Go ahead and try that and give me, ask me any questions that you have. We've got one more video to do on how to graph them, and then we will talk about that in a minute. Thanks, guys. Talk to you soon. Bye.